This is an introductory lesson on the vertical projectile motion in one dimension. We're going to look at the key concepts. What is a projectile? You need to understand that. What is a projectile? What is free fall? What is acceleration due to gravity? A projectile is an object which is moving through air, experiencing free fall after being dropped, thrown, or shot. We can say after being projected or after being launched, right? The object moves under the influence of the gravitational force only. And we're saying that the object is moving through air, experiencing free fall after being dropped, thrown, or shot. What is free fall? And we're also going to look at the gravitational force. Free fall is the motion during which the only force acting on an object is the gravitational force. Free fall is motion during which only force acting on an object is gravitational force. And then acceleration due to gravity. This is the acceleration of a falling object as a result of the gravitational force. And it is 9,8 meters per second squared. This is an approximate value. 9,8 meters per second squared. Downwards is always what? Acting downwards. Please take note of that. We're going to discuss more about the projectile motion in our next tutorial, but let's just look at this. We're saying that the acceleration due to gravity is 9,8 meters per second squared downwards. What does that mean? It means that every second, the velocity changes by 9,8 meters per second. Every second, the velocity of the projectile changes by 9,8 meters per second. Let's say we have an object that is launched from the ground. Right. I'll use 29,4 meters per second. That is the initial velocity. This object will move upwards, isn't it? But now, because the gravitational force is downwards, it means velocity is going to decrease. After 1 second, the velocity is going to decrease by 9,8 meters per second. So 29,4 meters per second minus 9,8 meters per second, we're getting what? We're getting 19,6 meters per second, right? And then after another second, the velocity is going to drop. 19,6 meters per second minus 9,8 meters per second, we're getting what? Let's see, 9,8 meters per second. See that velocity is decreasing until it gets to the maximum point. Let's say it's a D here, right? 9,8 meters per second minus 9,8 meters per second is now 0 meters per second. So at its maximum height, the velocity of the projectile is 0 meters per second. Then after this turning point, now the projectile is moving downwards. As it moves downwards now, the velocity is increasing. Take note. It is increasing. But at what? At the opposite direction. So from 0, it goes to negative 9,8 meters per second. Check that. At C and E, the magnitude of velocity is the same, but it's only that it is in opposite direction. It goes down, and then at F is going to be negative 19,6 meters per second. At B and F, the magnitude of velocity is the same, but it's different direction. And then we go down till it gets to its starting point. It started on the ground. So at the starting point is going to be negative 29,4 meters per second. Right, this is just an example. It's not like all the projectiles are starting at 29,4 meters per second. This is just an example trying to illustrate the projectile motion. This is negative 29,4, same as that in A in magnitude, but different direction. Okay, so it means if you have the initial velocity, you can easily find your final velocity. Let's say if the final velocity is big at the starting point. Let's say we started above the ground, it can move further downwards. After a second from G, it will be negative 39.2 meters per second. But we'll discuss more about the projectile motion in our next lesson. We'll discuss about the acceleration due to gravity. We'll discuss about the velocities. We'll also discuss about displacement. The other thing I want you to take note of before I end this tutorial is the time symmetry. The time it takes to complete the upward motion, this time, from there to there. Right? The time it takes to complete the upward motion is equal to the time it takes to complete the downward motion, which is from this part to this part. So time here and time there is just the same, isn't it? That is called time symmetry, but we'll discuss more in the next tutorial.